Hello Year 7. Today we're going to do a little bit about naming compounds. Then next lesson you'll be doing a SAM learning task which is already in the folder, so if you'd like to do it early, feel free. So what I'd like you to do today is follow through the PowerPoint with me and do the tasks that are in the PowerPoint that I ask you to do. And then at the end I'll tell you some optional extra tasks that you can do if you found it really easy and you finished early. So let us go on to the PowerPoint. Now, this relates to a GCSE topic. So you'll notice it says here C3 Quantitative Chemistry, Lesson 1, Naming Compounds. Now, you will do this again in GCSE, so if you've got the hang of this now, it's going to make it so much easier. There are the learning objectives, and I'd like you to try and answer this question here. So what does this mean? Write everything you know about it. Again, you'll need your periodic table. So I'm going to leave you a few seconds, so pause it, have a go, and I'm going to go on to the next slide. So now you should have paused it, had a go, and then paused it. I'm going to go on to the next slide now. Okay, calcium carbonate. You should know it's got 3 oxygen atoms, it's got 1 carbon atom, it's got 1 calcium atom. The name is calcium carbonate. The relative formula mass is 100 grams. You might have been able to calculate that. You would not know that it's a covalent compound. So the only thing really from GCSE that you don't know yet is, well, the relative formula mass, which we kind of looked at last lesson, and whether it's covalent or not. But everything else here you know, which is great. So, let's talk about naming simple compounds. So a simple compound of a metal and a non-metal, and if you look at your periodic table, the sort of right hand side, and we did this before, the right hand side, the section is non-metals, anything else is a metal. That's not too important right now, so but what I will do, I will actually, let's go on to the periodic table just in case we forgot whereabouts they are. So rotate view clockwise. So find boron on your periodic table. The boundary between boron and aluminium, that's like a line. Now think of it as a step. What I'm going to do is I'm going to go along, I'm going to go down, then I'm going to go along, I'm going to go down like this. So we did this before. So what you'll find is, you know boron is a, well, you know aluminium is a metal. I'm going to tell you that boron is a non-metal. This entire top row are non-metals. So that's the boundary there. And silicon is a non-metal. Germanium is a metal. Okay. Arsenic is a non-metal. Antimony is a metal. So that is the boundary. So anything in this top triangle here, they are non-metals. Anything else on the periodic table is a metal. So all of these ones in the middle, these are metals. All the ones on the left, these are metals. Hydrogen, you ignore hydrogen. It's a rogue element. Okay, it can act as a metal or a non-metal. So for now, that's why it's floating at the top, because we're not quite sure where to put it. Okay, so now that we've cleared that up. So, if you are writing the name of a simple compound, the first thing you do is you write down the name of the metal. Then you write down the name of the non-metal, changing the ending of the word to IDE. So I'm going to give you an example. So here, let me get my pen. So I've got magnesium and oxygen. Now, looking at my periodic table, magnesium is on the left-hand side, so I know that this is a metal, and oxygen is a non-metal. Okay, so we should know that oxygen, chlorine, well, and oxygen are the non-metals in this. So what do? You write the name of the metal first. So the name of this compound, so if these two things, these two elements are reacted together, magnesium and oxygen have reacted together, it has to have IDE on the end. And you know that if something is an ide, it is in a compound. I would take the first syllable and then write ide afterwards, just while you're starting to get used to this. So notice that I have chopped off all of this part of the word and just put "-ide" at the end. You get the hang of where you put the "-ide." So if you said magnesium oxygenide, for now you would probably get the marks. Okay, so if you wrote something like magnesium oxide, the examiner knows that you are talking about this is a compound, but this is not the correct name. You'll get the hang of it eventually once you've seen it enough. So it's magnesium oxide. So I'll let you pause, have a quick go at the other two. Now you should have had a little go and unpaused it. So this one is sodium, because that's the name of the metal. The metal always goes first. And the name, and because it is a compound, it's an "-ide. So what I'm going to do, there's the first syllable, right? Chlor. I'm going to write chlor. And then I'm going to write "-ide. So I've got rid of the "-ene" bit. So that is sodium chloride. This is this table salt. This is the stuff you put on your fish and chips, right? So let's do the last one. Iron. We should know that iron is a metal. And from the first question, we know that this will be iron oxide. So that is how you name a compound. Metal goes first and remains unchanged. The non-metal that is reacted to it, that is part of that compound, you chop the end of it off and replace the end with "-ide. Okay, so let's have a go at these. So what I'm going to tell you is that every element 1 is a metal, every element 2 is a non-metal, just to make it easier for you. So the first one, iron and sulfur are elements, but now they've reacted together to form a compound. That compound will be called iron sulfide. Magnesium and nitrogen are both elements, but they have now reacted together to form a compound, so it is magnesium nitride. Okay, so you will spot a compound if it has the letters I, D, E at the end. This is how you know this is a compound. I'd like to have a go at the rest, so pause the video, have a go at the rest of them, I'll unpause it and we'll go through the answers. Right, so you should have paused it, had a little go. Now I'm going to unpause, now I'm going to go through the answers. They're quite straightforward once you've got the hang of it. So number 3 will be sodium chloride, tin oxide, aluminium bromide, nickel iodide, zinc sulfide, and lithium nitride. If you didn't quite get the "-ide in the correct place, so maybe you wrote magnesium nitrogenide, or maybe you wrote nickel iodide, you'd still get the marks because you understand what you're supposed to do. You're just not quite familiar with the names yet. Now, the next part. If I've got a compound, so let's say I've got, I'll start that again. Let's say I've got some elements. Here I've got nickel and I've got sulfur. Ignoring this column here for now, if I had nickel and sulfur react together, I would get nickel sulfide. This is the old spelling. This is the new spelling. So nickel sulfide. If I had nickel, but the thing is, that is telling me I've got a compound of only nickel and sulfur. Now, what this slide is saying, what if we had oxygen in the mix as well? Well, writing nickel sulfide wouldn't do because it doesn't tell us that there is any oxygen there. We would have to write something else, and the chemists have come up with a way of naming this, and what you do is instead of writing the "-ide" on the end, you write 8. That is saying this is a compound of nickel, sulfur, and oxygen. So you see here, nickel plus sulfur plus oxygen will make nickel sulfate. Magnesium plus nitrogen would make magnesium nitride, but magnesium plus nitrogen plus oxygen is magnesium nitrate. So if you ever see 8 at the end of a compound name, you know oxygen is there, but it's hidden. You don't write nickel nickel sulfoxygenide. Okay, that's too much of a mouthful. Or you wouldn't write magnesium nitrooxygenide. Again, it's too much of a mouthful. So instead, we write the letters A, T, E. So now pause it, have a go at the others. Okay, hopefully you've had a go and now you've unpaused it. So once you've got the hang of this, it's quite straightforward. Sodium plus nitrogen plus oxygen, sodium nitrate. Copper plus sulfur plus oxygen, copper sulfate. And aluminium plus bromine plus oxygen, aluminium bromate. Which is good. Now, I'm just going to skip past this next slide. So, a formula uses the symbols of the elements in a compound. When there is more than one atom of each element, the number is always written after the symbol, which we did before. So, we're kind of recapping the particle diagrams, which we did. Now, what you have to be able to do, either given this particle diagram, or given this here, you have to be able to come up with the formula for that compound. So if we've got one carbon atom and two oxygen atoms, what is the formula for carbon dioxide? Using your periodic table, you should know the formula for carbon is a capital C, and the formula for an oxygen is capital O. Now that wouldn't be good enough, because what you're saying is there is one carbon and one oxygen, so then you put the 2 next to it. So let's have a go at the next one. Okay. Water. Now, here we have got hydrogen, hydrogen and oxygen. So we know there are 2 hydrogen atoms and 1 oxygen atom. So let's just say that I was trying to write the formula for this down. Well, I'd start off by writing capital H, capital O, because I know there is a hydrogen atom. I know the symbol for hydrogen is a capital H. I know there is an oxygen atom, and the symbol for oxygen is capital O. But I have got 2 hydrogen atoms, so I have to write a little 2 or a subscript 2 there. Now this is the correct formula, H2O, which is water. Now the formula shows the ratio of atoms in a compound. That means, let's look at carbon dioxide, because my ink isn't messing with the font. There is always going to be 1 carbon atom to 2 oxygen atoms. That is carbon dioxide. You cannot have, for carbon dioxide, you cannot have 2 carbons to 2 oxygens. That is something different. You cannot have 1 carbon to 4 oxygens. That is something different. Okay. For carbon dioxide, the ratio of atoms is always going to be 1 carbon to 2 oxygens, and it cannot change. Okay. Let's have a go at this. I'll do the first one. You're going to do the second 2. So, titanium oxide. For every titanium atom, well, I'm going to write a little 1. For every 1 titanium atom, that's 1, there are 2 oxygen atoms. 2. So I'm going to start off from my periodic table. I'm going to find out that titanium is this. There are 2 oxygen atoms. That's, well, there's my 2. So I know titanium is Ti, I know oxygen is O. So what's the formula? Well, there's 1 titanium atom to 2 oxygen atoms. I'm going to rewrite that because I don't like writing the little ones, but it helps me, maybe it helps me think about it. So the formula for titanium oxide would be this. 1 titanium atom to 2 oxygen atoms. And that would be correct. So I'd like you to try lithium oxide and aluminium chloride. So for lithium oxide, for every 2 lithium atoms, there is 1 oxygen atom. Then for aluminium chloride, for every aluminium atom, there are 3 chlorine atoms. So pause it, have a little go at that, and then unpause it when you're ready. Okay. So I'm going to move on. Hopefully we've got this. 2 lithium atoms to 1 oxygen atom. And then for 3, there is 1 aluminium atom. So I'm going to rewrite this because the font is making it look a bit weird. 1 aluminium to 3 chlorines. Now the font on this isn't good. This should look like A lowercase l C lowercase l 3. Okay. The straight line, you can confuse that with an I or a capital L, or so that's why we like to have curly letters. Okay. Now, I'm going to pause this again. I would like you to have a go at these. These are a little bit more difficult, but they're kind of the same. If you've got the hang of this, it's going to be really easy. So I'll pause it now, have a go at them, and unpause it. So you should have unpaused now, and you should have had a go. Silicon chloride. Every silicon atom, there are 4 chlorine atoms, SiCl4. Manganese, oxide. Every manganese atom, there are 2 oxygen atoms, MnO2. And for aluminium, for every 2 aluminium atoms, there are 3 oxygen atoms, Al2O3. So, hopefully that makes a bit of sense. And now, if we go back into this lesson, quickly have a go at this. So here you've either been given a name or a compound. Now don't worry about getting the wrong numbers next to it. This is just an exercise in figuring out what elements are there. So for example, calcium carbonate, you know there's calcium, you know there's carbon, and you know there's oxygen. So that would be a fine answer for me, okay? So calcium, carbon, oxygen, because it's calcium carbonate. Now here, this is zinc bonded with chlorine, so you know the name for this one is zinc chloride. So have a go at them. And then after you've had a go, unpause the video and then we can carry on. Now, we're going to do a little bit of balancing equations. So let's have a little look. I'm going to draw this out. So I'll get my pen out again. Let's draw the atoms that are involved in this. So here I've got 1 magnesium atom here. 1 magnesium atom. Here I've got 2 oxygen atoms, because remember this little 2. So I'm going to draw them joined together because this is an element. This is an oxygen molecule. There are 2 oxygen atoms joined together. Here, this is a compound called magnesium oxide. And I've got 1 magnesium and I've got 1 oxygen. Now, the law of conservation of mass states that mass cannot be created or destroyed. It is just converted. Now, if we look here, how many magnesiums do we have on the left-hand side? Just from our particle diagram. Well, we've only got 1 here. How many oxygens do we have? Well, we've got 2 oxygens here. Let's have a look on the right-hand side. How many magnesiums do I have? I've got 1 magnesium and I've got 1 oxygen. So at the moment, this is not correct because I've lost an oxygen, which can't happen. For this reaction to happen, you've got to have a balanced equation, which means you need to have the same number of magnesiums on the left-hand side and the right-hand side, and you've got to have the same number of oxygens on the left-hand side of the arrow and the right-hand side of the arrow. So, let's have a look. So first of all, how do we balance? Count up the number of atoms, which we did. We've got 1 magnesium on each side. How many oxygens do we have? Well, we've got 2 oxygens on the left side and we've got 1 oxygen on the right side. So what do we do? The numbers aren't balanced. So now we've got to add big numbers to make up for any shortages. In this case, so I'm going to stop using animation now. I'm going to start writing. So here, if you look, I've got 1 magnesium on the left and on the right. I've got 2 oxygens on the left and I've got 1 on the right. The reason why we do it in the middle is because we're splitting it down here. We're counting the left-hand side compared to the right-hand side. So I look, the magnesiums are alright at the moment, so I can leave them alone. They are equal, that's fine. This is not equal. Okay, I've got too many on the left, I've not got enough on the right. So what I do is I try and make this number bigger somehow. The only way to do that is find the oxygen and put a big number. So I increase it by 1. I had 1 of these before, now I'm going to say, what if I've got 2 of these now? So I can only put a big number in front. I cannot do this. This is not allowed. You cannot do that. You cannot put a little 2 underneath, because that changes the whole formula. That will no longer be magnesium oxide. So now that I've put a big 2 in front of this, we should know, because I've got 2 of these, it's the same as writing magnesium oxide plus magnesium oxide, right? So how many magnesiums do I have now? Well, let's recount. I've got 2 magnesiums. How many oxygens do I have? Well, now I've got 2 oxygens, okay? Because I've got 2 of these in total. Well, is that working? Well, the oxygens work, the oxygens are balanced. The magnesium is not. I have too few magnesiums on this side. So I'm going to go find the magnesium and I'm going to put a big 2 in front of it. Here it is. Big 2. Luckily, this is an element by itself. So all I'm doing is adding 1 magnesium essentially. 2 of these means that I've got 2 magnesiums and we are now balanced. Okay. I'm just skipping past the animation because we've done it. So there, we've got to this. Both sides have equal numbers of atoms. And if you want to, you can double check. And if you count it up, you will see, once you've finished, 2 Mg, that means there is 2 magnesiums here. 2 MgO, well actually that means there's 2 magnesiums there too. This means there's 2 oxygens, so let's have a look on the right. Well, there's 2 of these, which means there is 2 oxygens, so we're balanced. So this is a balanced equation. Right. I'm going to balance this one for you, and then I'm going to ask you to try the next one. Now, don't worry if you can't do this. This is really difficult. It is just a skill that you will learn over time. But you have to understand, as long as you understand why we are doing it, as long as you understand that we are trying to balance the number of atoms on each side, because we have to conserve mass, then that is perfect. First thing I'm going to do, I draw my line. I like to draw a line down the middle. If you want to, you can draw a particle diagram above, which might help you. So I'm going to draw the particle diagram above at the moment. So I've got 1 atom. This is a chlorine, Cl with a Cl. Then I've got a sodium atom bonded to a chlorine atom. Right. So on the left-hand side, I'm going to write all of the elements that I have. I've got sodium, I've got chlorine. The method that I use is slightly different because people like to write them in the middle. I prefer to have it on each side. Now you've got the same elements on both sides, so I'd write them again. Let's count up how many sodiums do I have on the left-hand side. Well, I drew my particle diagram, so I could just count the particles if I want to. Well, I've got 1. I've got 1 sodium on the left-hand side. Let's count up how many chlorines I've got on the left-hand side. Well, again, I've drew my particle diagram, so I've got 1, 2. Or you could look at this and look, oh look, there's 2 chlorine atoms. I've got 2 chlorines on the left-hand side. Let's look at the right-hand side. How many sodiums do I have? Well, I've got 1 sodium, and then I've got 1 chlorine. Is this balanced? Well, the sodiums are fine, but the chlorines are not fine. So what do we have to do? Find the one that you are short of. So I do not have enough chlorines on the right hand side. You go to that compound it's in and you write a big number in front of it. I can't write a 2 here. I can't write a 2 here. Not allowed. I have to do it right at the front. So now what I'm saying is I've got 2 of these. So because I've got 2 of these, I need to draw another sodium chloride because I've now got 2. Let's recount up my atoms now because this has changed. So let's cross these off. I need to recount. Well, how many sodiums do I have? Well, I've got 2 sodiums now. How many chlorines do I have? Well, I've got 2 chlorine atoms now. Okay. Well, if I look, the chlorines are now equal. The chlorines are good. Yeah, chlorine, 2 chlorines, 2 chlorines, that's good. But the sodiums are not. I've got 2 sodiums on the right hand side. I've got 1 sodium on the left hand side. So what am I going to do? I need to find a way to get more sodiums on the left hand side. So I'll find my sodium and I'm going to put a big 2 in front of it. So let me draw. Now that I've got a big 2 in front of my sodium, that means I've got an extra sodium atom. So now let's count them up again. Well, the chlorines did not change. The chlorines stayed the same because I did not change the number in front of here. So I can ignore the chlorines. But now I've got 2 sodiums. So now I've got... Let's have a look. Chlorines are still balanced. The chlorines are good. Sodium, I've got 2 sodiums on the left. I've got 2 sodiums on the right. So we are good. This is balanced. Okay. Now I'm going to have to get rid of the ink. Discard my ink. And then I'm going to maximize this. I would like you to have a go at... I'm going to make one up for you, I think. Yeah, I'm going to make one up. I'd like to have a go at balancing. So let's get this. Let's say I have got H2 plus Cl2, and that makes HCl. Okay, so this is hydrogen, this is chlorine, this is hydrogen chloride. In fact, I'm going to make it a little bit neater because it looks a bit... Oh, undo that. Right, whatever. That should be blank. What I'll do, pause it, have a little go while I sort this mess out that I've just made. Pause it, have a little go while I make it a bit neater. And then I'll go through the answer. It's an L. Okay. Hopefully you paused it, you've had a go, you've tried to balance it, and maybe you've got stuck or you got an answer. It doesn't matter. What I'm going to do is I'm going to start off by drawing. Well, H2 looks like this, doesn't it? That's what hydrogen looks like. H2, 2 hydrogen atoms stuck together. Well, let's have a look at chlorine. Cl bonded with Cl. That's chlorine. And that makes H bonded with chlorine, Cl. That's what we've got so far. So let's change the font to something a bit pinker. So I do a dotted line down the middle. What elements do I have in this equation? Well, I've got hydrogen and I've got chlorine. What about the right hand side? Well, I have to have the same elements because we've just said that mass is conserved. So I've got hydrogen and I've got chlorine. Oh. Find the proper, there we go, we'll get rid of this. Right, okay. I've got chlorine. Let's start with the left hand side. So this is the left hand side and this is the right hand side. Okay? To the left of the arrow and to the right of the arrow. Let's count up what I've got. Well, H2, I should know that means there are 2 hydrogens, but if not, I drew my particle diagram out and I can count them. 1, 2, 2 hydrogens. How many chlorines do I have? The same, okay? 1, 2 chlorines. Let's look at the right hand side now. How many hydrogens do I have? Well, there's my hydrogen. I know it's not got a number next to it or in front of it, so it must be 1. But just in case, I drew my particle diagram. I've got 1 there. And my chlorine atoms, the same again. I've got 1 chlorine atom. So right now, this is not balanced. I do not have enough hydrogens or chlorines. So I'm going to pick one. I'll just pick hydrogen because it's on the top. I'm going to find the thing that has hydrogen in. I'm going to put a big 2 in front of it like this. So now what that is saying is that I've got 2 of these. 2 of the whole thing. You don't just ignore half of it. You have to double the whole thing. You can't write little letters next to it. You've got to double the whole thing. So now that I've got 2 of these, that means I've got 2. If one of these was that, I've got to draw the second one, right? So I've got a second one now. Well, now we've got to recount because this is wrong. How many hydrogens do I have on the left-hand side now? Well, if this was 1, doubling that means I've got 2. But I drew my diagram so I can also count here as well. So I've got 2 hydrogens. So how many chlorines do I have? Well, here's 1. If I doubled it, I've now got 2. Or if I wanted to count, I'd go 1, 2 chlorines. Well, I've got 2 hydrogens here and 2 hydrogens here, so that is good. I've got 2 chlorines here and 2 chlorines here, so that is good. So this is now balanced. So if you were able to do that, then that is amazing. Okay. Now, after you've had a go at this, what you'll find is this is a task from the PowerPoint. So if you've already done this from the PowerPoint, you don't need to open that. If you'd like to have a go at an extension question, if you finish with loads of time to spare, there's the extension question. Could you finish your notes and email them to me, please? And that is all you've got to do.